Good day, everybody. How are you all? Hope you are doing great. Today we will work with a binomial probability problem. So I share my screen with you. Let's read from the top. So if the probability of a concrete beam failing from compression is 0.05, find the probability that from a sample of 50 beams, at least 3 beams will fall in compression. This is a case of binomial probability. So I've written a few things before I came to the class. This is a case of binomial probability problem because there are two particular outcomes or results possible. Either you fail or you do not fail. Now, small probability of success, in this case, the probability of the beam failing from compression is 0.05. My total number of trials of the sample size is 50. I want to find out what is the probability of at least 3 beams failing. Now, 3 beams failing means it can be starting from 3 anywhere up to 50. So probability of 3 plus probability of 4 plus probability of 5 all the way up to probability of 50. Question is, why am I adding this probability? I'm adding these probabilities because they are independent events. So either 3 can fail, or 4 can fail, or 5 can fail, or 6 can fail, up to 50. That's why I add all the probabilities of the individual's events. Now, to find the probability of x greater or equal to 3, that is at least 3, we will use the law of probability of complement events, okay? Law of probability of complement events, which states that if AC is the event, A exponent C is the event is the event complement. Complement means opposite, does not contain A, to event A, opposite to event A, then probability of the complement event is 1 minus probability of A. So probability of X greater equal to 3. What is the event complement to greater equal to 3? Any failure less than 3. So 0, 1, and 2. And we add the individual probabilities because these are independent events. Now, how do I find probability of 0 using binomial probability formula? So let me create some space for myself. So probability of 0, that is nothing is failing, is given by actually, let me write the probability in the binomial probability formula. So probability of R events happening out of N events in a binomial situation is given by N is the total number of sample size, C, R. Okay, so N total events, R is the number of events happening, that is multiplied by probability of success raised to the power of R multiplied by 1 minus P, that is the probability of failure raised to the power of N minus R. Okay, so N is your total number of events, okay. Small p is the probability of success, okay, and 1 minus p is probability of failure. So in my case, probability of say 0, nothing is failing, will be 50. This is 50 combination 0. Okay. I should also write NCR is number of combinations or possible arrangements of R events, or let me put R items. taken from n items. Okay, so this will be 50C0 multiplied by probability of failure, which is the probability of success in this case, is 0.05 raised to the power of 0 multiplied by 1 minus 0.05 raised to the power of n minus r is 50 minus 0. So it is 50C0, combination of 0 items taken from 50 items multiplied by 0.05 raised to the power of 0 is 1 multiplied by 0.95 raised to the power of 50. And that is equal to, we will use the calculator. So the first thing, let's erase the 0. So first thing, let's find out is 50C0. Combination of 0 items taken from 50 items. So first we'll type 50. Then we will press the math key. Then on the top row, we will highlight PROB. Okay, which stands for probability. Then I scroll down to NCR, okay, in the calculator, and then hit enter. And we will get 50C, and there will be an empty square at the bottom of C, which we will type 50C in the bottom square, we will press 0, okay, and then hit enter. So this is equal to 50C0. So 50, then math, 50 math, then highlight PROB on the top row, then number 3, then CR, bottom square 0, and hit enter. And the answer is 1. Okay, so if I move this a little bit up, P of 0 then equal to, P of 0 is equal to 1 times 1 times 0.95 raised to the power of 50, which is equal to 0.95 exponented to 50 is 0.0769. Now let's do P of 1, which will be 50 C of 1 multiplied by 0.05 raised to the power of 1 and multiplied by 0.95 raised to the power of 49, which is equal to, so first we do 50C1, 50 math, highlight PROB on the top, then NCR, and then it is number 1 in the bottom, hit enter, number is 50. So 50 multiplied by 0.05 multiplied by 0.95 exponented to 49, and that is equal to 0.20425. Okay, and then P2 is equal to 50C2 multiplied by 0.05 exponent 2 multiplied by 0.95, 50 minus 2 is 48. That is equal to, so 50, then math, sorry, 50, then math, then highlight PROB on the top row, then scroll down to NCR, and then bottom is 2. This is 1225 multiplied by 0.05 x square multiplied by parenthesis 0.95 x parenthesis, right parenthesis, then exponent 48. And that is 0.2611. Hence, P x greater or equal to 3 is 1 minus sum of these probabilities, 0.0769 plus 0.2025 plus 0.2611, which is equal to 1 minus, let's add these three probabilities, 0.0769 plus 0.2075, sorry, 0.2025 plus 0.2611 is equal to 0.5405 is equal to 1 minus 0.5405 is 0.4595. 4595. Let me clearly, okay, write this. Let's move this over. So P of X, so P of X greater, now let's use original thing. So P of X greater equal to 3, answer is 0.4595. Let's this is your answer. Is this correct? Let's check it out. How do we check it? Okay. We'll use the calculator to check it. Okay, so let me create some space. So let me use a different ink. So checking with calculator. With calculator. Calculator. Binomial function. CDF function. So P of X greater equal to 3, like we explained before, is equal to 1 minus the complement event, which is P0 plus P1 plus P2. And in our calculator, we have a P, this is binomial CDF, 1 minus binomial CDF. My N is total number of events is 50. My probability of success is 0.05. I'm adding from 0 to 2. Okay. X is always the last item I'm adding from 0. So I will go to my calculator, do 1 minus, then second verse, second key, then verse key. Okay, so 1 minus second key and then verse key, and then scroll down to binomial CDF, which is at the bottom, B as in boy in my calculator. Number of trials. So it asks me for trials. I will enter the number, which is 50, and then it asks me for p-value, probability of success, which is 0.05. So I type in 0.05. My x value, I will type is the last number in from 0 to 2. So 2, I type in 2. And then I will go to paste and hit enter twice. Put the cursor on paste and enter twice. Enter twice. Okay, if I move up a little bit, let's do it that way. So P X greater equal to 3, then equal to, I've done all the calculation and went on paste and entered twice. And the answer is, boom, the same answer as before, 4595. So this answer matches with the answer shown above. Hence, I can highlight this answer. 0.4595 is your answer. Okay. And I can write this also as answer. Which one should you use? Which technique? If you have the calculator, TI-84, you can use the calculator method, okay, without any hassle. And if you want to learn the formula, you can use the formula method. The important tip or hint I wanted to give you is if possible, use the calculator because it's much easier than using the formula. However, I wanted to show you how the formula in the calculator, what formula they built in the calculator, and what is the basic of that formula basis. And hence I used it, the formula initially to solve the problem and then use the calculator to get the same answer. I'll stop here today. Thanks for watching. And if you like this video, give me a big thumbs up. I really appreciate that. That motivates me to do more stats problem just for you. Thanks for watching. And if you like this video, share with your friends. You and your friends, please subscribe to my channel Math Science Topia by hitting the red subscribe button. I'll be back tomorrow with another stat problem. Do not forget to watch me. Thanks for watching. Take care. Have a nice day. See you.